Hello everyone, my name is Vamshi Gindam, and this is my final project presentation for the GSEN6383 Advanced Spatial Analysis and Design. My project is titled as Spatiotemporal Analysis of 2023-2024 Burglary Hotspots in Houston. In this project, I analyzed burglary incident patterns in Houston using spatial density mapping, emergency hotspot analysis, and super neighborhoods. The super neighborhood summaries. The main focus of this final project is comparison between weekday and weekend burglary hotspot behavior. The objective of this project is to analyze burglary hotspot patterns in Houston using 2023 and 2024 uh, incident data. There were three main goals. First, I wanted to identify which burglary incidents were spatially concentrated. Second, I compared weekday and weekend hotspots behavior using emergency hotspot analysis. Third, I summarized the hotspot zones using the super neighborhoods data so that the results could be explained using readable name areas. My original proposal mainly focused on 2023 burglary hotspots, like a kernel density hotspot analysis, uh, and all. During the project, I expanded the analysis to include the 2023 and 2024 comparison and the weekdays hotspot comparison. So this slide shows the data and the study area. I used 2023 and 2024 burglary incident data from Houston, Texas. Each burglary incident was mapped as a point location. I also used Houston super neighborhoods as the reference layer for the summarizing hotspots zones later in the analysis. All layers were projected to NAD 83 state plane, Texas South Central in meters. This map's just showing the burglary incidents of 2 years with the super neighborhoods data too, just to know the spatial context for the rest of the analysis. This slide shows the overall analytical workflow. First, I started separating the burglary incidents from the overall crime data. Then I uploaded the latitudes, longitudes, and the every details of the burglary hotspots into the ArcGIS Pro, then reprojected them to the state plane, NAD 83. Then I compared the kernel density bandwidths to understand how the density pattern changes at different spatial scales. After I created a year-to-year kernel density comparison between the 2 years. Then I used the combined data of 2 years for emergency hotspot analysis. The main part of the project was weekdays and weekends hotspot analysis. And after that, after separating the data by day type, I summarized the hotspot zones using super neighborhood and criminal and created a weekend minus weekday kernel density comparison. So here, this slide shows the kernel density bandwidth comparison for 2023-2024 burglary incidents. The 500-meter kernel density shows a fine scale pattern. It captures small location clusters, but it also looks more fragmented. The 1,000-meter kernel density gives an intermediate pattern. It smoothens the surface more than 500 meters, but it still keeps some local detail. 200-meter kernel density, so 2000-meter kernel density produces a broader neighborhood scale pattern. This is smoother and easier to interpret for general hotspot areas. The main point is that the kernel density bandwidth controls how detailed or smooth the burglary density surface appear. So the kernel density map should be interpreted as density surfaces, not exact hotspot boundaries. So this slide shows the density difference between 2024 and 2023. In this map, blue areas represent places where estimated burglary density was higher in 2023, and red areas represent places where estimated density was higher in 2024. I use this map as a visual density change surface. It helps show where burglary density visually shifted between the 2 years, but this map is not a statistical hotspot test. It is only a user to support the broader interpretation before moving to the emergency hotspot analysis. So this slide shows the combined 2 years emerging hotspot analysis results. The colored hexagons represent statistically significant hotspot zones. The darker red brown areas represent stronger or more consistent hotspot behavior. The lighter orange areas represent weaker or more intermittent hotspot behavior. White hexagons indicate areas with no significant hotspot pattern. This map gives the overall 2 years hotspot pattern before separating the data into the weekdays and weekend groups. One important point is that these are 2 kilometer hotspot zones. They should not be interpreted as exact street level burglary locations. So, after identifying the combined hotspot zones, I summarize them using the Houston super neighborhoods. The table shows the top super neighborhoods based on combined hotspot zone overlap. Midwest had the highest overlap, followed by the Sharpstone. The reason for doing this step is communication. Hexagons are useful for analysis, but super neighborhood names make the results easier to understand. These counts represent overlap with 2 kilometer emerging hotspot analysis zones. So they do not mean exact burger location inside those neighborhoods. This is the main comparison slide of the project. One on the left is the weekdays emerging hotspot results, and on the right is the weekends emerging hotspot analysis result. The weekday analysis identified 58 hotspots zones, while the weekend analysis identified 35 hotspot zones. This shows that the weekday hotspots were more numerous and more spatially widespread across the Houston. Before I get to the emerging hotspot analysis, I need to generate a space-time cube for the uh, locations of the individual uh, burglary incidents. So using that, I created the emerging hotspot analysis results. So, but I cannot get a visual space-time cube because there is no visually representation for that in that for the point data. So this is the best we can get from it. And weekend hotspots were fewer and more localized. This difference is important because it shows the burglary hotspot behavior changes when incidents were separated by weekday and weekend patterns. So the table summarizes these hotspot types for weekdays and weekend emerging hotspot analysis. Weekdays had more hotspot zones overall, with 58 compared to 35 on weekends. Both weekdays and weekends patterns were dominated by spor- sporadic hotspots, A sporadic hotspot means the area appeared as hotspot intermittently, like not continuously throughout the full time period. The weekend analysis had fewer total hotspots, but it had more new hotspots. Like it was not there before, but recently it became a hotspot. So the main interpretation is that the weekday burglary hotspots were broader and more frequent, while the weekend hotspots were fewer but showed never hotspot activity in selected areas. So these slides connect the weekdays and weekend hotspot results to named Houston areas. For weekdays, the highest hotspot zone overlap was in Midwest. For weekends, the highest overlap was in Greater Heights and the Greater Third Ward. This is useful because emerging hotspot analysis output is based on hexagons, but super neighborhood summarizes make the results easier to communicate. So instead of only saying where the hexagons were located, this slide helps identify which named areas are most connected to weekdays and weekend hotspot patterns. So this slide shows the weekend minus weekday kernel density difference. Blue areas shows where weekdays average daily burglar density was higher. Red areas show where weekend average daily burglary density is higher. Light or neutral areas show little difference. This maps gives a density-based comparison after uh, uh, after the analysis we had before, like neighborhood summaries and all. The important point is that this map shows density differences, not casual explanations. It helps identify where weekdays and weekend burglary density was relatively higher uh, compared to as per the daily, but it does not explain why those differences happen. So the main finding is that burglary hotspot behavior differed between weekdays and weekends. Weekdays hotspots were more numerous and more spatially widespread than weekend hotspots. And there were some of the diminishing hotspots too, even uh, mainly in the weekdays analysis. But there were include more hotspot, more new hotspots. The weekend has more new hotspots when compared to the weekdays. The super neighborhood summarize helped connect the 2 kilometer hotspot zones to readable named areas of Houston, and there were also important limitations. Emergency hotspot analysis results represent hotspot zones, not exact street level burglary locations. Kernel density map shows density patterns, not causes. Overall, the project shows there is one more limitation, which is uh, when interacted with the summary like super neighborhood locations. If the hotspot happens to be falling between like at the same time, like in two zones, it's gonna be counted as two as per the each zone. So that is also a limitation for this project. So overall, this project shows the weekday and weekend burglary patterns in Houston are not the same, and separating them gives a cleaner understanding of how hotspot behavior changes day time. Yeah, that's all for the presentation, and thank you.